So today's webinar is going to be more about the 6 strategies to improve the machine shop and the profitability. And so the agenda for today is mainly going through the initial introduction, followed by a brief description of what we mean by a manufacturing department. We'll then look at the challenges of the manufacturing department they face, and then introduce the Fusion 360 for those that are less familiar with. We'll move on then to the Fusion 360 in your manufacturing department with a series of scenarios to help illustrate the possible solution. And then we'll finish with the summary. Then a quick intro about us. Basically, I'm Kerim Soydan. I look after the Fusion commercial sales in Europe, UK, and the Middle East as well. And I'm going to let Jonathan introduce himself as well.
That's right. So my name is Jonathan. I'm a technical specialist in our Fusion 360 European team based in Barcelona. My background is actually in industrial design, but over the years, I've taken quite a number of products from the first concept sketch all the way to the machines and to production. So I look forward to guiding you through what Fusion can do for you in manufacturing departments.
So a brief introduction. So in this webinar, we're going to look at how Autodesk Fusion 360 can be used by CAM programmers, manufacturing engineers, and CNC machine operators to make a better use of the hardware and manufacturing departments to produce better parts and to do it faster. On learning objective will therefore be how using the automation can reduce the programming times to start machining sooner, how to get most of the 5-axis machine investment by simplifying the programming, and how in cycle inspections improve part setup accuracy and helps you to avoid the costly rework, and how streamlined design and manufacturing teams can collaborate effortlessly with building data management, plus a few other strategies to help you increase the profitability. So what do we mean by manufacturing department? Well, here's an example of a facility. This particular organization has grown to a point which there are defined departments within the facility. On the upper floor, we have some office space. We'll probably find the design offices, part programming, sales, finance, meeting rooms, and so on. On the lower floor, we have areas such as packaging, goods in and out, assembly and quality assurance, and we are interested in today, the manufacturing department. So now you may already have been there, or you may have been on the way. So, but as your manufacturing organization grows in size and the capability, it will naturally establish separate departments. And since each of the departments has its own focus, such as those in the example just mentioned, like design, production, quality control, finance, and more, choosing the right manufacturing software can empower your team to unlock the full potential of your manufacturing department. So now we're going to talk about the challenges. I'm going to leave Jonathan to drive the presentation now.
Just hopefully confirm with me that you can see my screen, Karim.
Yeah, we can see.
Okay, perfect. And you can see the challenges as well. So we're going to tackle a bunch of different challenges throughout this webinar. And that is, for one thing, we're going to look at what it means to be faced with design changes in the middle of our day-to-day work. We are also faced with a constant need to automate, and we'll look at what we mean by automation, how we can really maximize the use of our CNC machine investments, how we can, in general, improve part quality, and then also how we can fill the skills gap. And this is a hot topic, I know, across the world in different occupations. There is a real demand for highly skilled personnel. And especially, of course, in the manufacturing industries, this is something we're challenged with a broad range of different solutions that are available. But Fusion is a great partner here because it lets you really communicate your skills. Now let's look at what we mean by design changes. So design changes in general can be costly. I'm sure everyone on this call is very aware of that. The real cost is often by just not being able to communicate those changes. In those instances, software can often help because it provides a direct link between the design and manufacturing departments. In essence, it really enables an effective communication between departments. There's a huge need to automate, and automation can take on a wide array of meanings. So especially in manufacturing, there's a lot of different types of automation. We are now focusing on the automation within the design and manufacturing software. So how can we automate processes that we do daily, that we do maybe hourly or every minute? So tasks that are repetitive and where we can really make the use of software because software can help us to deliver repeatability and consistency across our processes, and therefore it improves our quality and our reliability as well. We face in many customer calls that customers have amazing machines standing around and just aren't using them to their fullest potential. So this is really key. If you have a machine investment, you want to get the return on that investment back as soon as possible. So of course, there's many ways to achieve this. For example, you can automate setup processes by using in-cycle probing. You can make full use of multi-access machines. I know many customers shy away from multi-access operations if they're not used to it, because it's really difficult to program in many cases, but there are tools to help with this. In-cycle probing also to be used for verification and not just for setup processes. So to kind of transform your CNC machine into sort of a CMM. So software can really produce safe and predictable NC code for your CNC machines because it is an automated piece and it understands how the machine is set up and how it should work. Improving quality is also really linked to automation and making the most out of a CNC machine investment. And that is because there are certain types of toolpaths, of course, for example, that can help you increase the quality. So increasing quality can directly affect your profitability because you avoid any need for costly rework. And if you produce quality, of course, that also positively influences your reputation, or the other way around, negatively. If you deliver bad parts, then it is more likely that you will not be able to gain more contracts in the future like that. So software can really help here as well, because it can help you utilize better toolpath strategies. It gives you the use of multi-access machining, and you can use automated setup and verification. And when we talk about the skills gap, what we mean is we're talking about the gap between skilled jobs and the workforce that is available. So we see a lot, especially in manufacturing, actually, that there's a very, very skilled workforce, but slowly aging. And with them also the know-how of software is aging, and it's difficult to go with the times somehow. So it's really vital for us to capture that knowledge that already exists and then make the most use out of that. So software can help here as well, because it can capture that know-how and enable people who are skilled to train others to follow their best practices and then refine over time, and thereby building up a resilient workforce that is ready to face any challenges that you might be faced with. So let's talk about what is Fusion, first of all. And when we talk about Fusion, it's really an integrated tool that helps you design, go from concept all the way to simulation, to verification, to manufacturing, all inside one tool. So we're talking about an associative integrated CAD-CAM solution. For a lot of customers, Fusion is mainly a CAD tool. For a lot of them, it's mainly a CAM tool. But both of the areas really profit from one another when you know what the other department is doing. Fusion is an integrated tool. So integration means it integrates different pieces of a product development lifecycle together. So as I mentioned, you've got CAD and you've got CAM. You've also got simulation, so CAE. You've got ECAD, all of that. It's also a collaborative tool because it is cloud connected and enables you to share know-how and share data sets and comments and information that is important to design and manufacture your products. And it is designed in a very accessible way. It is accessible both in terms of the price point that it's available at, but also in terms of just simply the user interface of how you learn and how you interact with the tool. The Fusion 360 framework is something quite interesting because at the core functionality, Fusion already offers a lot of possibilities. So you have 2D and 3D CAD and assembly modeling, as well as engineering tools like simulation and animations and things like that. You've got integrated additive plastic printing for more the model side of things, so you can drive directly FFF machines. And because we're talking about manufacturing, you even have integrated 2D and 3D multi-axis CAM capabilities, including even work coordinate system probing. So you can go in the core functionality of Fusion all the way up to 5-axis even. But there's also a lot more to Fusion, and that is what we call the Fusion extension framework. So there are several extensions that extend Fusion's base capability significantly in different areas that you might be focused on. So we've got the machining extension, which is the area that we're going to be focusing on the most today, of course, because we're talking about manufacturing. There's also the nesting and fabrication extension to extend Fusion's capability in order to nest pieces together from different designs and then be able to fabricate them using 2D cutting. Then we've also got the generative design extension as a kind of a flat rate for generative design. We've got the additive build extension to also be able to print in metal and powder bed printers and simulate that printing process, as well as the manage extension to add more data management and lifecycle management capabilities to Fusion. So this is a framework that is ever growing. Fusion is really at the core of the design and manufacturing investment for Autodesk. And therefore, it's definitely a great platform to build on if you're building out your manufacturing department. So in this webinar today, we want to tackle 6 different types of strategies to improve the machine shop profitability. And we've come up with these 6 strategies that we believe are really great starting points to get the most out of your machine shop, or to also evaluate how you can grow your machine shop or your manufacturing department. As a basis for this presentation, we want to talk about a model manufacturing department. And we're going to take a manufacturing department that currently consists of 4 machinists, and that's Jan, Sanjay, Lauren, and Patrick. And each of these are outfitted with a machine that they are manning. So Jan is working on a 2-axis Haas. We've got Sanjay on a Fanuc robo drill. We've got Lauren on a Doosan, and we've got Patrick on a 3-axis Haas. And driving all of this, we have Carl, who's sitting in the programming office, and he needs to understand the challenges and the capabilities of all of the machines that his operators are driving. So he's the one sitting in the office programming the parts and providing the NC code. The first strategy that you can really utilize is associative CAD and CAM. So what we mean by that is Associative CAD-CAM means you can use your CAD model to go from the design to machining faster because it is connected. Changes that happen in the design update associatively, so there's no file conversions needed. Inside Fusion, this looks like this. We can use Fusion in the design environment, for example, to patch up holes. We can use Fusion to build surfaces that might be needed for specific manufacturing tasks. And we can use Fusion also to build up our work holding. So there is already an integrated library of a lot of vices and work holding chucks that are available with soft jaws, for example, where we can use the design itself to modify the geometry and then build out those parts that we actually want to manufacture in order to hold our parts in place. Then going into the manufacturing environment, we can build our toolpaths based on those 3D design files. So while we're investing time into programming these parts and investing our knowledge, investing our time, we spend a lot of time, and then most of the time updates happen at the most inconvenient of times when we've invested all of it. So toolpaths are out of date. But with an AnyCAD connection that enables the automatic update between up-to-date parts and the toolpaths, you have updated toolpaths in no time. So you can really use Fusion for the work holding, for things like soft jaws really quickly. You can utilize it for associativity between CAD changes and your CAM toolpaths. So how might this work now in our manufacturing department? Well, first of all, it's important that every one of the programmers and the operators has their own Fusion 360 license, because this is how they can work together on the models. In the programming office, they've got the CAD models, and on the machines, they're also working on the toolpaths, of course. So if any updates happen in the programming office, then they will be pushed automatically, because it's an associative CAD-CAM system, to all of the programmers, all of the operators on the machines, and they will never be working with out-of-date NC code. The second strategy to improve and increase your profitability is to improve accuracy and the part quality. So what we mean by that is you should aim for producing accurate and high quality parts in, of course, as short a time as possible. And oftentimes those two challenges kind of oppose each other, because time spent also means quality, but we don't have that much time available. So what we need is toolpath strategies to speed up our part programming and improve what the final output will look like, essentially. So what we have here is we've got a mudguard tool, and this is a pretty complex part where we can spend a lot of time just coming up with different toolpath strategies. We've got transitions between steep parts and shallow parts of the tool, and this is where programmers and also machinists definitely spend most of their time just deciding on which toolpath strategy to use on which part of the model. Luckily, we have strategies like the steep and shallow strategy available, which can create a high quality toolpath that actually comes from PowerMill. We can set whether we want to use a fixed direction, which then increases the step over, or whether we use a variable direction. We can use normal passes, or we can even smooth the offsets to reduce the load on the spindles and thereby increasing the quality. We can also automatically remove the cusps at the junctions of those step overs, because that's where the step overs are largest. We can directly modify our toolpaths and trim away any parts that might be superfluous in our toolpath because they were programmed in a bad way. So this is how we can utilize the strategies that we have, and we're still not even talking about multi-access, but we can utilize these high quality and high efficiency toolpath strategies and editing capabilities to get the most out of just the machines that we have available. So in order to utilize this in our manufacturing department, we need to outfit Patrick, in this case, with the machining extension. So he gets access to the steep and shallow strategy and the ability to edit his toolpaths and trim away parts that he might not need, that might be programmed in a bad way. And in order to upskill Carl, we'll also outfit him with a machining extension. And note here that this machining extension that includes all of these high quality advanced toolpath strategies is not necessarily applicable to all of our workers in this company. This is a flexible solution. So we can say, you know what, everyone else continue to work with Fusion 360 in the base level, and we will upskill Patrick and Carl for now. The next step now is that we want to get our manufacturing department to utilize multi-axis machining. Multi-axis machining really lets us produce complex and high-value parts because they often contain features that just simply cannot be produced using simple 3-axis machining. So in order to utilize those machines, we also need multi-axis operations to utilize those tools that are available. And these tools are often very, very expensive and have a very high entry point in terms of just cost, but also know-how in how to control them. In Fusion, now we're going to start off with this part, which we could probably manufacture in several different setups on a 3-axis machine. But if we utilize multi-axis machining, then we can really get the most out of it. So what we're going to do is we're going to start off with an accessibility analysis and analyze which parts of the model can we access at which axis. So we can understand and gain more insight into the model itself. We can directly use 3+1 or 3+2 operations and also wrapped toolpath that use our 4-axis capabilities. Using these 3+2 positional setups, we can utilize also things like towers. If we use the rotary strategy, we can even machine non-cylindrical parts on rotary axes. So we can utilize really our full rotary table and thereby machine parts that otherwise we wouldn't have been able to before. And using automatic 5-axis collision avoidance, we don't have to spend time tracking the collisions that might happen, but even on very, very complex organic surfaces, we can specify exactly how we want our machine to behave, what the tool axis limits are, whether we want our tool to lean and lead in a certain direction, and thereby produce higher quality parts in a shorter amount of time. So we're really utilizing what we already know from the 3-axis machining, and we're applying that know-how and augmenting it with the multi-axis capability to produce really, really high quality parts in hard to reach circumstances that just otherwise would not be really possible. So now that we have used all of this, we can machine our pockets, even the ones that are hard to reach, that might even have particular undercuts. And we've even got post processes available that are prepared for multi-axis machining out of the box and free to use. So in our manufacturing department right now, we don't have any multi-axis capability available. So how do we outfit our colleagues with this and make use of it? Well, it makes most sense maybe to exchange Patrick's machine with upgrading it to a UMC with 5-axis, because he already has the know-how built up of the machining extension where he was increasing the part quality using steep and shallow machining and part trimming. So he can now apply that know-how and really make use of a multi-axis machine. We might also, now that we have this know-how, get another worker. So we've now employed Annika, and we're outfitting her with a Mazak vari-axis, also with a 5-axis machine. So in order for her to drive this, we can also outfit her with a new Fusion 360 license and the machining extension, and transfer the know-how between Patrick and Carl to her and get her up to speed in no time. The fourth strategy that we can apply to increase the profitability in our machine shop is to use advanced CAM automation. What we mean by this, we talked about it, is really going between design and manufacturing, because we have a need to produce reliable parts while still minimizing our time to market. So we can employ automated tools to enhance the processes that we do day by day. We can minimize the waste, and we can improve the consistency over all of the parts that we produce. So in this example, we can see that there is already a whole bunch of holes available that it would take us traditionally quite a long time to program, because you have multiple cycles just for each hole that you need to drill. So what we can utilize is the hole recognition, which is a feature that comes from FeatureCAM into Fusion and enables us to recognize hole geometries and automatically program all of the different cycles that might be necessary for each different hole in all of the different angles that we need. So also here we can make use of our multi-axis machining if we have it available, because all of the holes in the different axes can be made use of. Also, the steep and shallow strategy is a great example of this automation, because where we would traditionally spend a lot of time to decide which area of a part needs to utilize a parallel toolpath or a contour machining and so on, the steep and shallow strategy and the automatic collision avoidance can save us all of this time, because it decides all of this automatically. Another strategy is that we can utilize templates. So if we come up with a set of operations that we utilize a lot of the times, then we can save these operations in templates and apply those templates over and over again. So whether we have similar parts or parts where we just want to implement those strategies quickly, we use those templates and we can share those templates across our workforce. So our workforce is always working with the same types of templates. So with hole recognition, the templates, steep and shallow, automatic collision avoidance, we've got our associative CADCAM. We're really on the way to getting a lot more out of the investments that we've made and a lot more out of our manufacturing department. So in our manufacturing department, we've now got a pretty robust setup. We've got half of our workforce outfitted with a machining extension, and all of them with Fusion 360. Now, what we can do is we can say, you know what, Carl can be opened up to do other tasks. We can transfer his machining extension over to Sanjay. So if we want to, we can give access to Sanjay to the machining extension, or we can add it back to him, depending on when he needs it. We can even transfer the machining extension that Carl has available if needed, and thereby freeing up time for him to do other tasks. Now, the fifth strategy that I want to look at today is automated setup and in-cycle process control. Now, that's a mouthful to say. What we mean by this is that we want to utilize the tools to the fullest extent that we have available. And one of those tools that is greatly underutilized, I hear that in conversations every day, is to use probing and use automatic probes that are oftentimes just collecting dust in drawers because people are too afraid to use them because they're very expensive, or maybe they don't have the strategies available to actually use them. Manual location is really, really time consuming, as everyone on this call I'm sure knows, and it's very difficult to perform accurately because it's humans doing it. So we should be using a machine to do it, which is good at doing automated, highly accurate tasks, and therefore make use of the spindle-mounted probe to perform automated setup and part verification as well. So let's look at this example of my colleague Richard in Birmingham, who is clocking in a part. And this part is very, very hard to clock in because it has no real flat surfaces. So a lot of time is spent just manually checking. Now, if we use the in-cycle probe, we can directly check the location and the position of our part and get that information directly back into Fusion. So if we want to use an engrave, for example, on this part where we have a tiny tool that might snap easily, we want the logo to be positioned precisely on the center of the cylinder, then what we'll do is we'll set up an automatic probing cycle to probe for the location of this part. So we can set different points and then get that information back. What we can also do is we can check geometry directly. So if we need a very precise fit, we can utilize the probe to measure the tolerances that are available, get that information through a results file back into Fusion, seeing the results directly live inside Fusion, and then arranging our part using automatic part setup to rotate and translate the axes that we have available precisely in the location to make sure that our part is located where it should be based on its actual location in the machine. And I know that this is sometimes a mind bender, and I'm very happy to show this in demos to our customers. So if this is something that you're interested in and you do have a probe that you feel you're underutilizing, then please reach out to us and make sure to book a demo with us to check how this actually works. Now we can see here that the logo was placed perfectly. We didn't snap any tools, and all of this using in-cycle probing because we automated our part setup, we automated our location, and used all of the 5-axis capabilities that we have available on this part. So in our manufacturing department, we can even outfit another person, in this case, Lauren, with another machining extension because she also has an automatic probe and she can utilize this on the Doosan. Again here, if we feel she doesn't need it anymore, or there are only certain tasks or certain times when she needs this capability, we just turn on or off that machining extension for her flexibly. Now, the 6th part is not so much a toolpath strategy or editing of toolpaths, much more it's the basis of what Fusion 360 is built around. And that is cloud-based collaboration, because Fusion 360 is a cloud-connected tool. It's important, as we saw in the beginning, to be able to communicate design changes and to communicate also manufacturing requirements to our designers and engineers effectively and fast. So in our manufacturing department, we can see that everyone is working together. No one should be working isolated. Oftentimes, they are even spread out across the globe and working on similar projects, but you have programmers sitting in one location and then machinists in one other location. And this works across platforms, across Windows and Mac OS, for example. So we can have designers working on their designs and their drawings inside Fusion, and then communicate those designs associatively, directly cloud connected, and we can build up our toolpaths and our machining strategies based on this. All of this data is hosted, synchronized on the cloud, of course, accessible only to those people that you choose. And you have the capability to communicate directly on the models, being able to share links that you can allow downloads. You can password protect these in order to share also your models with stakeholders that might not have Fusion available yet. So you can invite people to the projects to bring them into your team and really enable a seamless collaboration between departments, between locations, between companies even. There's an integrated messaging and commenting service even, so we can add comments directly to our model, which will then pop up in real time directly inside Fusion. So we can effectively reduce the amount of emails that we're sending, make sure that we're acting on exactly what was told, and then communicate what we need for the manufacturing department as well. Utilizing things like animations as well is very useful also for manufacturing departments, because we can make use of information that the engineer or the machinist might have and communicate that across different roles. So Fusion 360 really enables you to communicate across different departments and locations, and it is especially useful for manufacturing and engineering departments, of course, because they often have very different requirements and different mindsets. And if you improve the communication between these two, you will also improve the quality of your work. So in our manufacturing department, all of this is really driven by what we call Fusion Team, and that is the data backbone of Fusion. So all of the data between all of our workers is shared on Fusion Team. Now, what we can do, though, as well, is we can enable all of this data to be accessed by other people. So we can, for example, get a production manager into this team environment with a team participant license. We can get sales involved. We can get the designers involved. So while there might be some roles that do require actual CAD and CAM capabilities, there are also roles that just need access to the data, to renderings, to the setup sheets, for example, in order to make offers. So there are different types of licenses. Fusion is a very flexible tool in order to do this, to outfit everyone with exactly that tool set that they need. Now, in summary, we've looked at how design changes can be tackled with Associative CAD-CAM. We've had a look at how the need to automate can be met by using automated toolpaths and automated setup. We've looked at how maximizing CNC usage can really be achieved by utilizing the multi-axis machines, or also even getting the most out of the 3-axis machines with automated toolpaths. We've seen how we can improve quality by utilizing high-quality toolpaths and using also automation and the machine itself to do tasks that humans are not that great at. And we've also seen how we can fill the skills gap in a manufacturing department because we can transfer knowledge that is built up over time. We can grow organically and healthily and build up a resilient workforce. So Fusion 360, as you saw, is really not just one CAD tool or one CAM tool. It is essentially a whole platform that enables you to do simulation, electronics. You can do your 2D documentation. You can collaborate using Fusion Team as a backbone. You have a commenting system. You have integrated data management. And all of this is really top-notch and highest quality. So I would recommend that if you want to learn more, then please go ahead and visit our dedicated machinist page, where you will find all of the information that is relevant for machinists and for producing parts. Also have a look at the machining extension, where you can find out more about all of these different toolpaths and strategies that I talked about today. And please feel free to send us an email to fusion360demo@autodesk.com. So if you feel that whatever you saw today was useful and interesting for you, then please do reach out. We're interested to hear from you. Also, if it's just feedback on what you saw, whether that's useful or whether we could have done something better, we'd love to hear everything. So please get in touch with us. Now, I've talked for a long time, so I want to give room for any questions that might have come up. I'm going to have a quick look at the chat and see there's nothing in there so far. Does anyone have any questions? Do you feel like you'd like to know something about what I've presented or anything else about Fusion? I'll just give you a minute to think about it and type it in the chat if you want to. So if there's no further questions, then I'd say have a fantastic rest of your day. Enjoy what you're doing. Get the most out of your machine investment, of course. And with that, thank you very much from my side, and see you again in the next webinar. Bye-bye.
Bye-bye.